express root 6 cos theta plus 3 sin theta in the form r cos theta minus alpha. The r is positive and exact. The alpha is in degrees quadrant 1 to dp. So the first step is to use the compound angle trigonometry in MF19 for cos, because we are using cos theta minus alpha here. So this is the formula. Because of the minus, we have to use the minus, the sign at the bottom. So the sign of the bottom, we have cos plus sin. So we use cos plus sin. And notice the square brackets. Without the brackets, we have r cos plus r sin. And now we compare the coefficients on the left and on the right. For the variable cos theta, the coefficient on the left is root 6, on the right r cos alpha. So we have the first equation, root 6 equals r cos alpha. And for the variable sin theta, the coefficient on the left is 3, on the right it is r sin. So we have the second equation, 3 equals r sin. So after we get the two equations, we use the fact that tangent is sine over cos. So we divide and we cancel out the r, sine over cos becomes tangent, and we use inverse tangent. In 2 dp we get the alpha, okay, in degrees. And because of the fact that we have this formula in MF19, Pythagorean identity, cos squared plus sin squared equals 1. So we square r cos and r sin, so root 6 and 3, and we add them, because after we open up the brackets and we factor out r squared, we get cos squared plus sin squared, which is 1. So the r is just the square root of 15 from here. Okay, so in conclusion, the r is root 15, the alpha is 50.77 degrees. The next step is to solve the equation. So from the first part, be careful, this is the from the first part. Now from the second part here, in the second part, this is not theta, but it's using x, and it's 1/3 x. So we replace the theta with 1/3 x, and because this is 2.5, we can replace this left hand side with 2.5, and then we can divide both sides by root 15, and now we find the base angle. So finding base angle means in this case we use inverse cos of this, because it is positive. We get the base angle in the first quadrant. Now look at the domain. The question, it says the domain is from 0 to 360, but that is for x. The angle we are dealing with is not x, it is 1/3 x minus 50.77 degrees. So we multiply everything by 1/3, 0 times 1/3, x times 1/3, 360 times 1/3, and then we subtract 50.77. Minus this, 120 minus 50.77, we get this. So the actual modified domain we can use is this domain from minus 50.77 to 69.23. And remember the quadrant rules. In the first quadrant everything is positive, second quadrant only sine positive, only tangent positive, only cos positive, and the angle calculation, quadrant 1 base angle, quadrant 2 180 minus, quadrant 3 180 plus, quadrant 4 360 minus. Now if we look at this domain, we can only use the first quadrant base angle, and actually we can use the fourth quadrant negative angle. So for the fourth quadrant negative angle, that is just minus base angle, and for the base angle, yeah, it's base angle. So to solve for x, we add 50.77 to both sides. So plus 50.77 we get this, plus 50.77 we get this, and then we multiply by 3. So this times 3 we get this, times 3 we get this. For the final answer, we can just leave it in one decimal place for angle in degrees. Alright, I'll see you again.